we are excited to offer this new course, Verification and Validation of LS-DYNA Simulations by Al Tabi. Here is a little bit about Al Tabi, and this course is not possible without the more than 25 years experience of doing LS-DYNA simulation on large scale and various problems. The outline of the course is, as you can see here, the course is divided into 3 parts. The first part is kind of introduction, and then the second part is validation, the third part is verification. So in the first part, introduction, and then the definitions of verification versus validation, the differences between verification and validation, and then verification and validation methods, steps, and procedure. Can I bet the farm on simulations? This is going to be answered throughout basically the course, and the history of simulation also will be presented briefly. In the second part of the course, which is verification, so the first section of this is variability in simulation results. Things you have control over, contact, element, formulation, and other things. Things you don't have control over within the simulation. So these things will be discussed in detail. Then how to tell if your results are correct. What are the things to look for in the simulation? Especially this becomes important when there is no experimental data. So there are some useful outputs that you can take a look at. For example, D3HSP and the message file. When you run simulations on different machines, you get different answers sometimes. So that's going to be explained. Single precision versus double precision code. Truncation errors, round-off errors. These are going to be discussed and the effect on the simulation results. MPP versus SMP computers. So we start with introduction to MPP, and then we'll discuss these differences and then ways to reduce these differences in prediction when you run a simulation on MPP versus an SMP machine. Mesh convergent criteria. So mathematical equations to describe how we're going to do mesh convergence, and then a Fortran code will be given to you as part of the course so you can use. Mesh convergence and erosion criteria. Anytime you activate erosion and failure, there will be issues with mesh convergence. So there are 4 methods in which I'm going to present to reduce the effect of mesh dependency and failure. The third part of the course is validation. So there is quantitative versus qualitative validation. Quantitative validation is the most important. Qualitative is basically comparing the movies from the test and movies from LS-DYNA or LS pre-post output, basically, and compare frame by frame and other methods in order to compare the behavior of the simulation relative to the experiment. Quantitative validation is basically looking at the predictions in terms of acceleration and other measures in which I'll talk about in detail. Then I'm going to talk about experimental data and the lock of it and the verification and validation. Then within this, I'll talk about test repeatability. When you do an experiment, what are the things that you have to output so you can use them in verification and validation? And then finally, we'll talk about validation matrices. So in the time domain, we can look at magnitude phase matrices, single value matrices, and analysis of variance matrices. In the frequency domain, this is something relatively new, so we'll discuss some of the validation measures in the frequency domain analysis as well. So I hope to see you in the course, either online or on-site courses also can be requested. Thank you.